In a video earlier in the playlist, we considered this population model. The function n of t equals 251 times e raised to the 0.01 t approximates the United States population in millions of people, where t is the number of years since 1990. And we were asked several questions, including this one: in what year will the population reach 500 million people? And at that point, we hadn't talked about solving exponential equations. So we got out our calculators, we typed the function into y equals, and then we scrolled through the table until we saw 500 for the first time. And then we approximated the answer using that. Well, now we do know how to solve exponential equations, so I want to reconsider this problem. So 500 should be the number that goes in for n of t, because that's the population in millions of people. And so now I'm supposed to solve this equation. Well, I can do several things. I think the easiest way to go about this is to get the exponential part by itself. So I'm going to divide out 251. And I have e to the 0.01 t is equal to 500 over 251. And at this point, there's two really nice things to do. If we follow the methodology we were taught from our book and in the videos, we just take the natural log of both sides. I actually prefer to think about it as rewriting this as a logarithmic statement. So the exponent is equal to the log base e, which is the natural log of 500 over 251, and then t equals the natural log of 500 over 251 divided by 0.01. I'm going to write that as 100 times the natural log of 500 over 251. And now I get, so let's see, 100 times the natural log of 500 over 251. That's about 68.92 years after 1990. So that would be in the year 2058 and then 0.92 years. Okay, so in what year will the population reach 500 million? Well, if I take this very literally, during the year 2058, we're not quite to 2059, we would reach 500 million people. But this is a model, so I would also understand rounding this to 69 and just saying 2059. And about the year 2059, the population will reach 500 million people. I think it would be reasonable, based on what we've done, to say 2058 or 2059. I'm imagining rounding t up to 69 years. Maybe we were instructed to do so. We really weren't, but we could imagine that. On a lab, you were asked to do a problem like this using your graphing calculator by scrolling through a table. On the next lab, you're going to be asked to revisit that problem very much the way I revisited this problem, and now solve it by solving an equation.